Okay, everybody. Hey, hope you're doing great. Sorry I can't be with you there today. Here's what we got going on. So as you can see, we're on page 91. So we're going to work on this warm-up problem here to start us off on lesson 2-2, which is all about having equations that have variables on both sides of that equation. So now we're graduating to equations that have maybe an x or a y on both sides, not just one side. So read through our problem here with Jackson and Brian and the car wash, and maybe think about these questions to kind of get you going. I guess, how could you describe the money that each boy has collected? What quantity will you represent with a variable? And lastly, what's the relationship between, I guess, Jackson's earnings and Brian's earnings? Okay, so think about those. Pause the video. Go ahead and give it a shot, and let's see what we can do here. Okay, welcome back. Hope you guys are doing great. Here's what we got going on. So we want to create an equation by writing, an expression for each one of the boys, for Jackson and for Brian, about what they have in terms of money, right? I think Jackson has 14 checks and $15 in cash. All right, if I were going to write that down, I could say, okay, so he is 14x plus $15. All right, that's my buddy Jackson there. What about Brian? He's got 7 checks and $50 in cash, right? He has 7 checks. Plus $50, right? I think X is going to be the value of each check. It tells us that all the checks are for the same amount. So we don't know what that is, but we know how many checks each boy has. So I think that's what we're going to use X for. The relationship between their earnings, well, they collected the same amount of money. So I know that the amount of money that Jackson, right, collected is equal to the amount of money that Brian collected. So there you go. So what is the total amount of money that both boys collect? So here is our fancy equation, that we have, and maybe you drew a picture or whatnot to figure this out. But yeah, we can solve this, and maybe you did some guess and check, but it looks like at the end of the day, it wants to know how much they collected in total, right? Well, the amount they collected in total would be $170. Okay? And again, today is all about, hey, can I solve equations that look like this? We have a variable, the same variable, on both sides. Okay, so let's go ahead and we're going to get going with today's lesson. So there you go. Let's take a look at example 1. So go ahead, flip to the next page. We're going to be on page 92, and let's take a listen.
How do you use inverse operations to solve equations with variables on both sides? Think about this question during the lesson. Jonah and Lizzie are both making smoothies. Their smoothies will have the same number of fluid ounces. Jonah uses 6 ounces of juice, and Lizzie uses 12 ounces. Jonah uses 4 containers of yogurt to make his smoothie. Lizzie uses 2 1/2 containers of yogurt to make her smoothie. How many ounces of yogurt, X, are in each container? One way we can solve this problem is to draw a bar diagram that represents the situation. Then, we can use it to solve for X. The top bar will represent Jonah's smoothie, and the bottom bar will represent Lizzie's. The darker part of each bar represents the amount of yogurt, 4x for Jonah and 2 1/2x for Lizzie. The lighter part of each bar represents the amount of juice each of them used. 6 ounces of juice for Jonah and 12 ounces for Lizzie. We need to divide the bars to compare the two smoothies. The first column represents 2 1/2 eggs for both of them. The third column represents 6 ounces of juice for both of them. The second column represents the remaining part of each smoothie. For Jonah, that's 1 1/2 X ounces of yogurt. For Lizzie, it's the other 6 ounces of her juice. Look more closely at the second column. You can think of 1 1/2 X as 3 copies of 1/2 X. And we can also break Lizzie's bar into 3 equal sections of 2 ounces each. So 1/2 of X is 2 ounces. What's X? The diagram shows that X is equal to 4 ounces. Another way to solve this problem is to write an equation and then use inverse operations to solve for X. How does the bar diagram help us set up the equation?
Okay, so a couple things. One, that whole bar diagram, guys, was a little confusing there.
Helps show the relationship between the quantities. 4x plus 6 is equal to 2 1/2 X plus 12. Subtract 2 1/2 X from both sides of the equation. Why should we subtract 2 1/2 X from both sides? We subtract 2 1/2 X from both sides to get the variable terms on one side of the equation. Notice that, since 4 is greater than 2 1/2, it makes sense to subtract 2 1/2 X from both sides. Now, we have only one variable term, and it has a positive coefficient. Subtract 6 from both sides to get all of the constant terms on one side of the equation. Again, we have only one constant term left. Here's an equation that we definitely know how to solve. If you rewrite 1 1/2 as 3 halves, then you can multiply both sides by the multiplicative inverse, 2/3. So this method also shows that X is equal to 4. That means there are 4 ounces of yogurt in each container. Now you can solve equations when there are variable terms on both sides.
Okay, so that was a lot to take in there, guys. But just remember, so that's what we're going to do today. We're going to work on having these equations on variables on both sides. All right, let's take a look at this one here. Okay, so we have a sunflower. It says Class A was given a sunflower with a height of 8 centimeters, and it grows at a rate of 3.5 centimeters a week. Class B has a sunflower with a height of 10, and theirs grows at a rate of 3.25 centimeters per week. After how many weeks are the sunflowers the same height? Okay, so we want to write an equation that says that really compares the two heights of them, right? I know Class A, theirs starts at 8. That's where we get this plus 8 from. And it grows at 3.5 centimeters per week, right? The other class, theirs grows at 3.25, right? 3 1/4. And you could use the mixed numbers if you want. Okay. We need to gather or collect our variables on one side. Here's my trick for you. Always move the smaller variable, right? In this case, that's the 3.25. So I want to move this variable over here. Opposite operations say subtract. So I'm going to subtract 3.25 from both sides. 3.5 minus 3.25, right? All I'm left with is really just 1/4. Right, or 0.25. Now I've got to move 8 over here to the other side. We do that with subtracting 8. 10 minus 8 is 2. So I'm left with 1/4 W equals 2. And again, you have a fraction. We don't divide by 1/4. We multiply, right, by its reciprocal, 4/1. So multiply here by 4 over 1. This turns into 8. Right? That's what W is equal. Remember, W, they told us up here, is the number of weeks. So the sunflowers are the same height after 8 weeks. Okay, so onward we go. So that was example 1. Let's go ahead and move on to example 2. Here we go.
Teresa earns a weekly salary of $925 and a 5% commission on her total sales. Ramon earns a weekly salary of $1,250 and a 3% commission on sales. What amount of sales, X, will result in each of them earning the same amount for the week?
So again, one way is to use a bar diagram to show their earnings, okay? And then, again, set their earnings equal to each other, right? I want to know when are they going to be equal to each other. So when will Teresa's earnings be equal to Ramon's earnings, right? And that's what they've done when they write their equation there. Again, now they're solving their equation, right? We've got variables on both sides, and we're off and running. So again, there's about as complicated example as we get. And now we move on to example number 3.
Kelsey withdraws $25 per week from her bank account. Each week, Chris deposits $15 of his allowance and $20 earned from dog walking each week into his bank account. After how many weeks will they have the same amount of money in the bank?
Okay, so again, example 2, and I know we flew through example 2 there. Example 3, just like example 2, okay, we want to know after how many weeks, right, is the money that they have in their accounts equal to each other. So again, we have to come up with, you know, first off, what is X going to be, or what is X going to stand for? Well, in this case, X is the number of weeks, right, that have gone by, right? If we think about the first equation, why are there 2 terms, right? Why are there 2 terms on the right? Well, you've got to remember, every week Chris deposited both his allowance, right, his allowance money, and his money from dog walking, right? So each is multiplied by the number of weeks. So that's why we see 2 variables over there. Okay. Again, they've moved the smaller variable. When we think about, okay, here we are right here. 25 smaller than 35, so they're moving that over. So that's why they're adding that to both sides, right? Then they don't have any choice. They've got to move 10 over with 550. Subtraction takes care of that. We divide by 60, and we figured out X is 9. Again, X is the number of weeks that go by, right, for them to have the exact same amount of money in their accounts. Okay, so hopefully now we're going to go on to the try it here for example number 3, and we'll be able to work on this together. Alright, so this one says solve this equation. Here we go. First things first, I need to combine these y's. So 96, and then I've got negative, be careful, 4.5 minus 3.2. So that's going to be negative 7.7y. And then this is equal to 5.6y plus 42.8. Okay. I'd like to move this over to the other side, so I'm going to add 7.7. So we're going to add 7.7y. All right, that goes away. 96 is equal to, let's see, that's 13.3y plus 42.8. Again, 42.8 has no choice. It's got to move over here to the left with 96. Subtract 42.8, right? Opposite operations will do that for me. All right, 13.3y. Let's see. This is going to turn into 0.2 and 3 and I think 53.2. Okay. So we got some decimals here, not the best numbers in the world. We need to divide by our coefficient, 13.3. However, when we do that, I do believe we get a good number, right? I get 4. Hopefully that's what you got as well. So there we go. Solve the equation, very straightforward. Bam, we solved that for y. Okay. Let's move on to our favorite page. Okay, so we'll move on here, and we'll get to key concepts, and we'll go through these real quick. Maybe if we can zoom in. Can we zoom in? Magical person running the show. Thank you very much. Okay, so here we go, guys. Let's go through these real quickly. And first one, how do you use inverse operations to solve equations with variables on both sides? Okay. Well, in order to do this, right, in order to solve these problems, we're going to use inverse operations to combine all of the variable terms on one side and the numbers, or the constant terms we call that, on the other side. So we will, I'll just say, combine, let's write here, pen, variables, all right, on oh boy, combine variables on one side and constants, those are numbers, on the other. Okay. Question number 2. Why are inverse operations and properties of equality important when solving equations? Well, the inverse operations, that's just a fancy word for opposite operations, that lets us undo, right, numbers, right, or undo operations. So we can say, let's say inverse operations, which I've abbreviated as inverse ops, let us undo operations to solve equations. Okay. You know, the whole properties, gang, that just says, hey, if you're going to subtract 4, you know, over here on this side, you have to subtract 4, you know, on the other side. That's what that's all about. All right, let's work on question number 4 here real quick. All right, so question 4 is about Maria and Liam. And Maria earns a 20% commission on her food sales. Liam earns a weekly salary of $625 plus a 10% commission on his food sales. Right, this is a lot like example number 2. What amount of food sales will result in the two earning the same amount? So we want to come up with an expression for Maria's earnings. Then we want to come up with an expression for Liam's earnings. And then we're just going to set the two expressions equal to each other. So Maria earns a 20% commission, right, on her food sales. Again, food sales is our variable, right, which I'm going to let that be F. So Maria's commission is 20%. So 20%, right, as a decimal is 0.2. And whatever her food sales are, she gets 20% of that. So we would just multiply those two together. So I'll say 0.20F right? And that's got to be equal to Liam's earnings. So Liam gets $625 every week, right? Plus 10% of his food sales. Well, 10% of his food sales will be 0.10 F, but then he gets $625. Okay? All right, so solve this equation. I don't really have much of a choice. I need to move this 0.10 over here. We're going to subtract that from both sides. So 0.20 minus 0.10, right? If we subtract 0.10, that gives me 0.10 F, and that's equal to this 625. We just now have to divide by 0.10, so divide by 0.10. And I get $6,250. Again, that's not how much money they're making. That's how much the food sales have to be, right, in order for their salaries or the money that they make to be the same. So $6,250. Okay, let's look at number 5. Selma's class is making care packages to give to victims of a natural disaster. She packs 1 box in 5 minutes and has already packed 12 boxes. Okay, so there's her rate, right? She has 1 box in 5 minutes. She's already done 12, right? Her friend Trudy packs 1 box in 7 minutes, so not as quick, and has already packed 18. How many more minutes do each of them need to work in order to have packed the same number of boxes? Okay, so Selma packs 1 box in 5 minutes. And she's already packed 12. So we could say, hey, 5x plus 12, right? There's her expression, right? Trudy's looks very similar, right? Hers is 7x plus 18. Again, x is minutes or time. All right, why don't you guys give this one a whirl on your own, right? I'm going to give you a helping hand because I've run out of room. Move 5x over here. Okay, go ahead and move 18 over there. All right, let's see how we do. All right, go ahead and go. Take a pause. Break. Okay, so hopefully you've tried this on your own now. And if you've done that, right, you've realized that, okay, hey, I would subtract 5, I would get 2x. I would subtract 18, and I would get negative 6. And then you would solve that, and you'd get negative 3. And then you'd think to yourself, well, x is supposed to be number of minutes, right? So here's what we've done. So this is perfect. We've all fallen into this bear trap. So when we get something like this, guys, we have to understand that, hey, this doesn't make sense. So I probably haven't written my equation correctly, right? Now, I could have written it correctly the first time, but it wouldn't have been any fun because then we would have gotten the right answer. All right, so let's backtrack real quick. All right, I still think this part is good, and I still think this part is good. What's not okay, right, are these two expressions here. You've got to remember, do they pack at different rates? Of course they do, right? So if I were to give them 35 minutes, how many boxes will each one of them pack? Well, if Selma packs every 5 minutes, in 35 minutes, and she does 5, she would get 7 boxes done. All right, Trudy not as quick in 35 minutes, right? She does 1 every 7 minutes. She's only going to get 5 done. Okay, so I think we have to account for this somehow. So our equation is going to look just a smidge different, right? We're going to have x minutes divided by 5, right? Plus 12, okay, for our friend Selma. Trudy's going to look similar. It's going to be x over 7, x divided by 7, plus 18. Okay, now I've written these as x over 5. Best way to think about this is really, this is the same as 1/5 x, right? X over 7 is just 1/7 x. Okay, so now I think we're a little bit better. Okay, so here's what I want to do. Let's go ahead and let's move this over here, right? Let's move our variables. Again, they're just fractions. I know they don't look like them. They're just fractions. Move them over here together, all right? And we're going to be good to go. You guys try this, though. So pause the video. You guys try to solve this one, right? We've got 1, here, I'll write it over here. You've got 1/5 x plus 12 equals 1/7 x plus 18. So you guys pause this. Go ahead and solve it. I'll solve it here magically. It'll appear here in just a second. Go for it. Okay, welcome back. Wow, look at all that writing that's there. All right, so when I subtract 1/7 from 1/5, right, 1/5 minus 1/7, that's when I get 2/35. If you had a decimal here, that's okay. Then we just have to get rid of that. I multiplied by the inverse, 35 over 2, right, and that's how I came up with, well, we have 6 over here times this 35 over 2, which turns into 105. So again, this is 105 minutes. Whew, okay. All right, so we did those. We just have the 2 at the bottom, so we're going to tackle those, and then we're going to move on with our day. Okay. All right, let's see. Oh, we've got 3, 6, and 7 to do. Okay, here we go.